লাস্ট ডেতে পেন্ট করাচ্ছিলাম, রাইট? Okay, I'll move on. So, as we have discussed the classification of paints, the barrier coating, I guess, the constituents of paints, pigments, and extenders and fill forming materials. Until this, I have completed the part, right? Okay. So next, I will moving on to the dryers. So actually, the dryers are modern dryers are cobalt, manganese, lead, zinc, etc. So what they do, and they do dissolve the hot oil. Hello, are you recording? Okay, they dissolve in the hot oil, and what dryers does, they after dissolving the hot oil, they do reduce the drying time, has been considerably reduced, and the reduction of drying time sometimes is very efficient depending on the constituents of the paints, and sometimes it forms wrinkles. As Protima's last day, it's the drying time definitely form wrinkles, and that again depends on the constituents of the paints ingredients, how the thinners are and how the extenders are, how the vehicle is. So according to that, considering all those situations in mind, so dryers have been changed in order to reduce or increase the drying time. Okay, too rapid drying, very high rapid drying is also not desirable, as because it definitely form unwanted wrinkle. Okay, the dryers acts as the catalyst and promotes the oxidation polymerization, as I mentioned last day, which accelerates the drying of the film. Then the thinner is added to dissolve the film forming material and to reduce the concentration of paints for better handling as well as brushing. Okay, it has been it has been added to reduce the concentration of the paints, and it has been also added to dissolve the film forming materials. Okay, it has also been termed as diluents. So, and the example of diluents or thinners may include as aliphatic or aromatic naphtha fractions. Okay, and solvents such as turpentine also being used as your thinners. Okay, the usefulness of the turpentine, most of the industry or even in household materials, they use the turpentine oil. It could be common actually. The aromatic naphtha fraction or aliphatic fractions are hardly being used because they are expensive, because that's why they are used the turpentine oil. The turpentine, okay, it is cheap, and also the disadvantages of the turpentine oil is the low volatility. Okay, even it is low volatile, but it maintains the fluidity. Okay, it maintains the fluidity of the freshly applied film for reasonable period of time. Okay, that's why people generally use the turpentine. Even though it has a very low volatility, it is a drawback, but for the regular household purposes, turpentine is good enough. Then another constituent is lacquer. Lacquer is a liquid containing composition containing cellulose esters or ethers and plasticizer without or with in presence of resin. Okay, what is that? For that, lacquer is a liquid containing composition, liquid coating composition containing cellulose esters, ethers and plasticizers. Basically, lacquers must have flexibility in the chain, so that's why they have taken the use of cellulose esters or ethers or plasticizers, which have generally oxygen or a nitrogen group in the main backbone of the carbon chain, so that it gives the flexibility. See, the carbon-carbon bond strength is very high compared to the carbon-oxygen or carbon-nitrogen bond strength. So you have a oxygen in between or a nitrogen in between, like in ethers, you have the oxygen in between the carbon chain. So when it rotates, when attrition or some other unit operation comes in operation, so it should be malleable. It should not, if it is very hard, so there will be crack on the prints. That's why lacquer plays a very important part. So during these processes, it should be, or during brushing, it should be coated evenly. These ethers or cellulose esters or plasticizer is kind of material. I will come into that. So what it does, it relaxes the tension inside the your media. Makes the medium malleable. Okay. Lacquers employ ethers, esters, ketones even also can be employed sometimes, and alcohol also to provide the desired volatility. Okay, and by virtue of the evaporation of solvent, they are also called non-convertible coating. Okay, so see, a ketone or alcohol or ethers or esters has been dissolved in a certain kind of solvent, and as a function of solvent going out, it forms a permanent coating. So it's a non-convertible coating on the surfaces. Okay, so then basically you heard about the wood lacquer, the plastic lacquer. So these are non-convertible. They will be wiped out from the surface, but it cannot be replaceable. The anti-skinning agent, it is very rare, sometimes also used. Certain anti-skinning agents has been added in order to prevent the gelling and also skinning of the finished product before the application of paint by brushing or by spraying or by dipping. So what it does, so anti-skinning agents, it added to the paint to prevent the gelling and the skinning of the finished product. Okay, I think you heard about the term gelling. Gelling, tomra jano, what do you mean by gelling? Anybody?
No, sir.
Jano na?
না স্যার পড়িনি তো।
Okay, জেলিং হচ্ছে এমন একটা, ধরো অ্যালিফ্যাটিক আনস্যাচুরেশন, you have aliphatic unsaturation or aromatic unsaturation in a system. Okay, so before gelling or gel point is a typical point when the it cross link between the এই যে ধরো switches, these are cross link material. Okay, gel point is the point where the cross linking starts, means the molecules entangled with each other. Even in the paint, তোমরা 3D paint এর নাম শুনে থাকবে, that what is 3D paint? It is the molecular entanglement, it form the 3D structure. Gel point is the onset point of the 3D structure, 3D structure. So if you apply the 3D paint, it not on the surfaces, it not only forms the permanent painting, also very durable painting. So gelling is very important in terms of that. So if you achieve gelling, if you want to achieve gelling, or if you want to go for the 3D painting, so you add, so what you do, you do apply the anti-skinning agent, which is very expensive, and also 3D painting is very expensive. Understood? By virtue of a particular polymerization process, the gelling starts, or the gel point. Polymer পড়বে, you will get to know what in details what is gel point, what is gelling. Okay, so এই একটা বেসিক আইডিয়া যে 3D স্ট্রাকচার অনসেট যখন থেকে হয়, যখন থেকে 3D দুটো মনোমার যখন পলিমার ফর্ম করে, 3D পলিমার. So the gel point or gelling is that point when it starts forming entanglement in the system. Okay, so next is the plasticizer. As I mentioned, what is plasticizer? Plasticizers are low melting solids or liquids, definitely low volatile, to provide the elasticity to the film. ঠিক আছে, আগে যেটা বলছিলাম, the film should be malleable, elastic যদি না হয়. আচ্ছা, what is elastic limit, what is plastic limit? Chorodeep, what is elastic? What is plastic? Difference between those two? From class 7 8
So
knowledge.
from the elastic limit, we can get back to the original position, but after the plastic limit, if we cross that, we cannot return the original position again.
Okay, so in the elastic limit, it follows Hooke's law. Beyond elastic limit, it does not follow the Hooke's law. Okay, there will be a permanent deformation on that. Okay, ঠিক আছে. So plasticizers, what it does, the plasticizers is a low melting solids or liquids, all of low volatility, which provide the elasticity to the film and thus prevent the cracking of the film. ঠিক আছে, elasticity দিয়ে ফিল্মের ক্র্যাকিং resist করে, it resists the cracking of the film by providing the elasticity. Not only example, any ethers, esters are the plasticizers as mentioned in the lacquer also. Okay, the like triphenyl phosphate, dibutyl phthalate, castor oil, these are used as the plasticizers along with the paints. Resins, well mentioned, resins required for water-based paints containing no oils. Okay, অনেকে oil paint করে ঘরে, somebody does oil painting in home, somebody does water painting in home also, because water painting is user friendly, cheap. Oil painting is expensive, and once you do the oil painting, you cannot change it. So water painting, so suppose after 1 year you would like to change the watercolor, so just wash it out and again you can put the different paint. So in that way, it's not durable, but it is replaceable. So resins are required for water-based paints like no oils, with no oils, and depend on vinyl acetate, acrylic, or butadiene styrene polymer resin as the film forming materials. Okay, examples of natural resins are copal or rosin, while that of synthetic resins are urea formaldehyde, acrylate, vinyl or silicone. This urea formaldehyde resin, এটা থেকে তোমাদের প্লাস্টিকের সুইচ গুলো বানানো হয়. Acrylate paints, you have heard about that acrylate paints, that acrylate is the resin. Vinyl or silicone resins have also been used. Silicone resins is being registered because silicone resins is corrosive in nature. So silicone resins, sometimes if you use the silicone resins, you have to use the fire resistant material along with that, because this is very prone to film, means heat, burning, and also very corrosive. Finally, the binders. The binders have been added to fix the paint on the coated surface, provide toughness and the tenacity, and it actually makes the film tenacious and also glossy. Okay, so alkyd, silicone, and cellulose resins are the examples of binders. So alkyd, silicone, and cellulose resins are the example of the binders. So these are all the constituents of the paints. As I mentioned, the pigments I have mentioned, the difference between dyes and pigments have been discussed, extenders, film forming materials, dryers, thinners, lacquer, anti-scaling agent, plasticizers, resins, and binders. Okay, this is now, if I complete the manufacturing process of paint, that will be all about paints and varnishes. Acha, did you get the class notes? So I've sent two or three notes, right? One for water and one for cement, and another for water, কুলিং টাওয়ার ওয়াটারের জন্য আরেকটা পাঠিয়েছি। ওকে, একটা কনফারেন্সের পেপার। ওকে, very good. So now I'll be discussing the manufacturing process of, I'll be sharing a slide, the paint. Wait, okay. Can you see that? কালকেও আগের দিন হচ্ছিল, ওটা কেন হচ্ছে জানি না। আমি প্রেজেন্ট নাও এন্টায়ার স্ক্রিন করছি, সেটা আসছে না। আমি ইউর এন্টায়ার স্ক্রিন করলাম, হ্যাঁ এইবার আসছে, ওয়েট আসছে। Can you see it? দেখতে পাচ্ছ? Okay, this is the schematic or PFD of a your what do you tell, the paint manufacturing process. It's a pretty simple thing, pretty simple process to prepare paint and finally for the packaging and storage. So basic operation, as you see, you just follow these things, follow your image. The basic operation in the manufacture of paint is the dispersion of pigment particles. Okay, pigment particles, generally pigment particles are often mixed with extenders. Okay, no, only pigments have not been fed, it has been mixed with extenders and then it has been fed. Generally it has been done that way. Okay, so pigment particle with extenders in a medium, here it has been mentioned as vehicle. So pigment in a paint vehicle to produce uniform stable system, this would be our aim. So pigment particles often with extenders in a paint vehicle medium to form a stable system. How it has been done, it is shown in the steps. First, the process of pigment dispersion. It essentially consists of three methods, three processes. Okay, one would be the dispersion. First would be dispersion, second would be the wetting, and third would be the stabilization of pigments along with extenders in vehicle. Okay, first disperse korte hobe, then wetting, and then stabilization of the particles in the vehicle. Once it is done, you have got a stable system of the pigments in the vehicle. Okay, first, in the first step, pigment and vehicle are mixed in a high-speed mixer. This is the high-speed mixer. It's called a flat tech mixer. You can see a agitator is placed in between, and there are baffles over there. Okay, so basically it's an agitator vessel যেটা mixing এ তোমরা পড়েছো. So pigment and vehicle are put over there in a high-speed mixture, and then mixture are fed to a grinder or a high-speed disperser. Here generally they use the ball mill. Okay, from here it has been fed to a ball mill or pebble mill, etc., to break down the aggregates of the paint particle, of the pigment particle in the vehicle. Okay, so in the first step, pigment and vehicle are mixed in a high-speed mixture, and then the mixture was fed to a grinder or high-speed disperser. The dispersion involves breaking down of bigger aggregates or agglomerates to smaller units by high-speed disperser or mills like ball mills, pebble mills, sand mill, etc. Okay, generally ball mill use kora hoy. Okay, then all the grinding mills generally utilize the application of first shear, attrition, and impact. Three processes, three methods: shear, attrition, and impact, to effectively break down the pigment particles or the pigment aggregates, you might tell. So after grinding, the mill base is mixed with other paint ingredients in the high-speed mixture again. This is the second mixture. Other paint ingredients depending on your requirement, whether you add lacquer, whether you add colorants, plasticizers, that again entirely depends on you. Here itself, for different grade of paints, you add different additives in the second stage. Okay, in this stage, it is added in high-speed mixture, and if necessary, with the tinting agents in the subsequent mixture also. Okay, and so another thing is that here it is high speed mixture. Here the speed of rotation can be adjusted generally from 5000 to 1 lakh rpm, depending on the viscosity of the paint you want. Okay, if you want very high viscous film, the speed of rotation would be lower. If you need a low viscous film, paint, your speed of rotation will be very higher. But again, another drawback will be that if your speed of rotation will be very higher, what will be the drawbacks? What will be the drawbacks? Anybody? If the speed of rotation is higher, অনেক যদি স্পিড অফ রোটেশন অনেক বেশি হয় তাহলে কি হবে? What will be the situation then? Like it will be, see what the processes are: attrition, ki hoy, attrition, shear and impact. Okay, the particles will be break down, aggregates will be break down to very smaller particle size will be very smaller, the surface area will be very high. Okay, once the particle size will be very smaller, and the power required to achieve that will be very high. So you're aiming for a paint of, let's say, rupees 100, but the power you are putting in to grade that material out will be very high. একদম ইকোনমিক দিক দিয়ে এটা আনফিজিবল. সো দেয়ার হ্যাজ টু বি এ সার্টেন তোমার যে রোটেশন স্পিড হ্যাজ টু বি মনিটরড in that aspect. And also definitely যে তুমি কিরকম ফিল্ম চাও, what viscosity of the paint you need. So depending on that, your speed will be monitored in the second. In the first phase, it is constant throughout because you are feeding the same pigment, same kind of pigment and this thing, your vehicle over here. Okay, in the second step, you are adding the additives to get the paint out in the final step. So the speed of mixing is very important in the second step. So okay, and then before getting the packaging and storage, before it is packed and stored, the few tests have been performed. That is very important: the viscosity test and the degree of dispersion test. Those are carried out with the finished paint. Important, another, the straining of paints is being done also. The straining of paint is done to remove contaminants, and it is generally utilize the metal or synthetic fiber gauge or screen to do that. The paint passes through the hopper of the filling machine where it is filled into the cans on drums and labeled and then packed. So this is the process of paint manufacturing, and this is all about the paint. Okay, next I'll be moving on the chlor-alkali industry.
স্যার বলছি স্প্রে পেইন্টের জন্য কি সেম মানে ফ্লোচার্টই ফলো করা হয়?
একই রকমই ফ্লোচার্ট ফলো করা হয় স্প্রে পেইন্টিং এর জন্য. অনলি থিং ইজ দ্যাট আফটার গেটিং দ্য পেইন্ট আউট, এবার স্প্রেতে তোমাকে হোয়াট ইউ নিড ফর স্প্রে পেইন্টিং, স্প্রে পেইন্টিং তোমার পেইন্ট তো দরকারই হবে. ইউ নিড দ্য
পেইন্টিং গ্যাসিয়াস ফর্ম লাগবে এমন?
হ্যাঁ,
পেইন্টটা গ্যাসিয়াস ফর্মে তো লাগবে।
প্রথমে তুমি পেনটা নিলে, এবার তুমি পেনটাকে আন্ডার রিডিউস প্রেসার তুমি ওটা গ্যাসে কনভার্ট করে তুমি স্প্রে করতে পারবে। বাট প্রিভিয়াসলি তোমাকে সবসময় এটা করতে হবে, আর একটা গ্যাস পার্জিং আন্ডার রিডিউস প্রেসার তোমাকে ফাইনাল স্টেজের আগে ওটা পার্জ করতে হয়। এটা তোমার স্প্রে পেইন্টিং এর জন্য লাগে। ঠিক আছে,
ঠিক আছে স্যার।
নেক্সট আমি কি বললাম? chlor-alkali industry. Okay, next will be the chlor-alkali industry. Generally chlor-alkali industry te amra chlorine and sodium carbonate manufacture ta take care korbo. So today I will be discussing about the sodium carbonate manufacturing technique. এটা একটা সিম্পল প্রসেস ফ্লো ডায়াগ্রাম, আমি এটা ইন ডিটেইল একটা পরে পাঠিয়ে দেবো, যেটা বড় পিএইচডি থাকে। এটা একটা সিম্পল, সো দ্যাট আই ক্যান তোমরা বুঝতে সুবিধা হবে তোমাদের। ওকে, সো ফার্স্ট ফার্স্ট এইখানে দেখতে পাচ্ছ তো? ক্যান ইউ সি দ্যাট?
হ্যাঁ স্যার দেখা যাচ্ছে।
Okay. Okay. First, this is the brine. Okay. This brine is pumped to, this is ammoniated brine. আচ্ছা আমি কি ফ্লো চার্টটা দেখাবো? ফ্লো চার্টটা দেখালে I guess it is, এটা তোমাদের একটু বেশি সুবিধা হবে। পিএফডিটা ঠিক আছে, এটা আগে বলি তারপর পিএফডি দেখাবো। Okay, what is being done? First, the purified brine, এই যে এখানে দেখো purified brine, এটা purified, okay? It is being pumped to a ammonia absorber where it dissolve ammonia, এই যে এইখানে দেখছো ammoniated brine, okay? এখানে একটা ammonia absorber থাকে, the process is called Solvay process, okay? এইখানে একটা absorber থাকে where the purified brine comes in, it mixes with ammonia in the gaseous form, right? বুঝতে পারছো? So purified brine solution, এইখানে একটা টাওয়ার থাকে, this is called, এখানে যেরকম কার্বোনেটিং টাওয়ার আছে এখানে থাকে অ্যামোনেটিং টাওয়ার। So in the ammoniation tower, the brine mixes with ammonia and little bit of carbon dioxide okay? Hello, তো শুনতে পাচ্ছ? ওকে, it mixes with, কি বললাম আমি, mixes with ammonia, little bit of carbon dioxide over there, okay? And now you have the ammoniated brine, which will be the major ingredient to produce your this thing, কি বলে, sodium carbonate, okay? Now in the ammoniating tower you pass the purified brine, it mixes with ammonia, gaseous ammonia over there, and little bit of carbon dioxide to form the ammoniated brine. So this is the by this way ammoniated brine, and this ammoniated and partially carbonated brine, partially carbonated কেন বলছি, because you are putting some carbon dioxide over there, and from where the carbon dioxide is coming, I'll be telling you, because you need not to feed the carbon dioxide as such. The carbon dioxide produced from the system itself can be utilized to carbonate in that stage, even though you require very little amount of carbon dioxide over here, but it need not to be fed from outside. It is the system inbuilt carbon dioxide which is being fed over here. So this ammoniated and partially carbonated brine is pumped to carbonating tower or sulfate tower. This is over here, okay? This is passed over here for cleaning duty. So what is being done in this tower? In this tower, the carbonation of ammoniated brine is being carried out via following the principle of counter current. Okay, the co-current and counter current heat exchanger পড়েছো? Did you read about these things? এখনো পড়ানো হয়নি co-current and counter current? Okay. Counter current মানে হচ্ছে যখন when you are passing your fluid in the opposite direction, counter current, and you are passing the fluid in the same direction, it will be co-current, okay? Let's say আমি একটা ছোট্ট জিনিস বলে দিচ্ছি, let's say you have a shell, okay, and you have a tube. Inside the tube you have one fluid flowing in a certain direction, okay, and in the shell and through the shell you are pushing another fluid. Let's say ভেতর দিয়ে oil যাচ্ছে, বাইরে দিয়ে তুমি water পাঠাচ্ছ, okay? One is being heated up, one is being cooled down. So heat exchange is being taking place. If this fluid is being sent in the same direction, that is called co-current. If it is flowing in the opposite direction, that is called counter current. Basic idea is that, okay? In details আমি বলছি না, এটা বুঝতে পারলে তো যেটা বললাম? হিট এক্সচেঞ্জটা হচ্ছে, বাট যখন depending on the flow direction, so it's co-current or counter current. So here what I mentioned, so in this tower, carbonation of the ammoniated brine is being carried out on the principle of counter current. The ammoniated brine solution is pumped to the top of the tower, okay, and flows downwards to meet the current of carbon dioxide, which is admitted at the bottom of the tower. বোঝা গেল? ওপর থেকে from the top of the tower, the ammoniated brine solution flows downward to meet the current of carbon dioxide, which is being admitted at the bottom of the tower. Achha, from where it is being found, the carbon dioxide, I'll be coming to that. Okay, these carbon dioxide, what I mentioned, the counter current. So carbon dioxide and ammoniated brine solution, ওটা উপর থেকে নামছে, এটা নিচ থেকে পাস করছো, some amount of, and it has been, the carbon dioxide is being absorbed by your brine solution. Okay, so ammoniated brine, so NaCl aqueous, here you can see the NaCl aqueous, NH3, carbon dioxide, water reacts to form sodium carbonate and NH4Cl. Okay, I'll be coming to that, but some part of the carbon dioxide has been counter current is being coming out from the carbonation tower from the top also. It has been, as it has been counter current, if it is co-current, is coming down with the sodium carbonate and NH4Cl, but in this it is not coming down with the sodium carbonate, sodium bicarbonate and NH4Cl, because it is the counter current. Okay, as it is coming out of the carbonation tower from the top, যে carbonation tower from the top আমি বলেছিলাম, that carbon dioxide is being again utilized in the first step. কি বলেছিলাম? Brine with mix in the ammoniation tower, ammoniating tower, it mixes with ammonia and little bit of carbon dioxide. That carbon dioxide is coming out from the top of the carbonating tower. Okay, so you need not to bother about that. So that it reacts with each other. Okay, it reacts with each other. So ammonium chloride and crystalline sodium bicarbonate is formed. Now, as I mentioned, from where the carbon dioxide is coming, it is coming from the lime kiln section. Here the limestone, আগের দিন বলেছিলাম, I think you remember those things. The lime kiln section, the limestone is burnt to produce carbon dioxide and lime. Okay, that carbon dioxide is being sent to the carbonating tower, and the latter, that is the calcium oxide, and along with water is being sent to the lime slacker. In this lime slacker, lime is slacked with water to produce the calcium hydroxide or the lime of milk. Okay, or the lime milk. Here the lime slacker reacts with water to form calcium hydroxide or the milk of lime or lime milk, which is again pumped to the ammonia recovery section. I will be coming to that. So until now we have sodium bicarbonate crystal and the ammonium chloride in aqueous form is being formed. Okay, so it is a continuous process. The sodium bicarbonate will form continuously along with the ammonium chloride. The tower gradually fouled as the bicarbonate cake deposits on the surface, on the cooling surface. Okay, so what to do? How to get rid of that one? So generally একটা মেকিং টাওয়ার থাকে, মেকিং বা প্রোডাকশন লাইনে 4-5টা টাওয়ার এভাবে কন্টিনিউয়াসলি রান করানো হয়, সো দ্যাট এই প্রসেসটা যে ফিল্টারিং ক্লগ না হয়ে যায়। ওকে, সেটা তোমাদের না জানলেও হবে। সো এই ডিপোজিশনটা আটকানোর জন্য আমাদের তাড়াতাড়ি রোটারি ফিল্টারে কুইক করতে মানে ইয়ে করতে হয়, কি বলে, ফিল্টার আউট করে নিতে হয়। সো নাও the towers are constructed with a number of cooling boxes and sloped baffles so that sodium bicarbonate settles at the bottom and pumped as slurry. এই যে ক্রিস্টাল ফর্ম হচ্ছে, ক্রিস্টালস উইল ডেফিনেটলি, আগেটা বললাম যে ক্রিস্টালস, সোডিয়াম কার্বনেট ক্রিস্টালস গ্র্যাজুয়ালি ফর্ম এজ এ কেক and foul করে দেবে, কেক ডিপোজিট হয়ে ফাউল করে দেবে। ওকে ওকে, ammonia, so it will be so ammonium bicarbonate crystals will be formed and it will form cake and the cooling surface will be fouled. So ammonia buffers, এখানে একটা খুব important thing, the ammonium buffers have been used at ammonia buffers ki hoy, it has a very high pH of 10 to 14. So that ammonia without, if you don't use the ammonia buffer, what it does, without ammonia buffer, a hydrochloric acid byproduct will be produced and what will do, it will do the hydrochloric acid byproduct would render the solute acid solution acidic. কি হবে এখানে অ্যামোনিয়া বাফার, অ্যামোনিয়াটা আমরা ইউজ করছি, we are using ammonia, so if you don't use the ammonia buffer over here, hydrochloric acid will be produced as a byproduct which will convert the pH of the system from 10 to 3 or 1 or whatever it may be. So it definitely the solution will be acidic. Okay, once this solution will be acidic, the precipitation of sodium bicarbonate will be arrested. The sodium bicarbonate, the basic clause of sodium bicarbonate to precipitate out, it has to be a basic media. So ammonia buffer solution has to be used in addition to that to always maintain the pH of the solution be over 10, so that continuous sodium bicarbonate will be produced. Okay, now the problem regarding the crystals of the bicarbonate can be eliminated to certain extent. Okay, if you change the construction of the tower, the towers are constructed generally that to avoid the situation, the towers are constructed with a number of cooling boxes and sloped baffles. Okay, so that the sodium bicarbonate settles at the bottom and pumped as slurry to the rotary filter. Okay, এবার rotary filter থেকে, rotary filter now you have the filtrate from the rotary filter and you have the solid from the rotary filter, the residue of the rotary filter. Okay, from the residue of the rotary filter, if you consider the residue of the rotary filter, the liquid contains ammonium chloride. Okay, and the residue of the rotary filter, here heat the product of sodium carbonate, you got the soda ash over here. Okay, so the solids from the rotary filter are calcined at 200 degrees centigrade, okay, in a gas fired or steam heated calciner to get the soda ash as the final product. Okay, so what will be the reaction? The sodium bicarbonate heated up to form sodium carbonate, carbon dioxide and steam. Okay, that carbon dioxide, here you can see over here, that carbon dioxide is again being fed in the carbonated tower also. So only this, the lime kiln, you are utilizing the sodium carbonate, the limestone, naturally abundant limestone to produce carbon dioxide, and the rest you need not to add up any cost. The ammonia is also being recovered in the ammonia recovery section, so you need not to feed the ammonia gas, you need not to feed the carbon dioxide to run the process. Okay, now the filtrate liquor from the rotary filter is sent to the ammonia recovery section. What ammonia recovery section, the basic reaction calcium hydroxide, প্রথমে বলেছিলাম যে lime slacker, what it does, it produce the milk lime. Okay, calcium hydroxide. Okay, so that calcium hydroxide has been fed in the middle of the ammonia recovery section. It reacts with ammonium chloride to form ammonia. That ammonia is being fed to the ammoniated brine solution. So it is a continuous process, and you are getting calcium. How it is being done? The filtered liquor from the rotary filter is sent to a pair of ammonia stills. It is not so easy. It's ammonia recovery section consists of a pair of ammonia stills. In the first still, free ammonia is driven off by steam heated reboiler, and the bottom containing combined ammonia. প্রথম স্টিলে free ammonia is driven off, bottom থেকে combined ammonia পাচ্ছি আমরা, containing combined ammonia fed to the combined still. Next still is the combined still. First is the free ammonia still, and second is the combined ammonia still. In the free ammonia still, ammonia is driven off by the steam heated reboiler, and from the bottom you are getting the combined ammonia. So it has been fed to the combined ammonia still, okay, and it reacts with the calcium hydroxide or milk of lime to get the ammonia gas and calcium chloride as the byproduct. Okay, this ammonia gas is being again fed to the ammoniated brine solution for the continuation of the process. So this is all about sodium carbonate soda ash production process. Okay, আমি class note পাঠিয়ে দেব পরে. So this is all about that. Next class I will be starting the chlorine thing. Okay, chlorine একটু বড়, আমি আজকে এই ক্লাসের chlorine টা করাবো না. So next class I will be starting with chlorine. Nowadays, to end the class, before ending the class, the modified Solvay or dual process has also been nowadays adopted. The difference in the dual process from the Solvay process, okay, that the ammonium chloride is recovered as the byproduct in the dual process, unlike it is being used for the ammonia recycling in the Solvay process. Okay, এটা হচ্ছে dual process এবং Solvay process এর difference. Okay, thank you.